The warmest welcome to each of you. It's wonderful to share this virtual space with many of participants across the EMEA regions today. My name is Tanvi Huang, and I am your account manager in chemistry and life science if you are based in Germany, Austria, or Switzerland. Your active participation today is crucial to our talk about Reaxys Academic Edition, a full solution to research and education. But first of all, let's start with the rich history of Reaxys, stemming from the print form of major chemical handbooks to the development of online databases and client-server systems. Some of you may know or still remember that Reaxys evolved from the Crossfire system launched in 1992. Fusing three authoritative databases into one premium data source, namely the Crossfire by Stein, Handbuch der Organischen Chemie, and then the Gemelin, which is the printed version of organometallic chemistry and inorganic chemistry since 1771, and the patent chemistry database from WIPO, EPO, and USPTO. And following the sunset of Crossfire, Reaxys was born in 2009 and meant to enhance the research process for chemists and scientists in several ways. Very similar to the former databases, Reaxys stands out, of course, in reaction search, in providing access to a vast number of experimental property data points, and leading to precise connection between the substances and their properties. And then in 2013, 2014, a real implementation approach technologically enabled the extension now of the content. But of course, it did not stop there. Reaxys is continuously being developed, adapting to new indexing, search, retrieval technologies, while preserving the well-used and functionally improving usability and adding new features and data all the time. But only until 2016, a total rewrite of Reaxys led to the launch of the new user interface as we know, so similar to what we know nowadays, and still offering extensive structured search capabilities for substances and reactions. But now also supporting bioactivity searches and retrosynthesis, and even the integration of PubChem. And with the extensive global exertion of target and bioactivity, the algorithmic interpretation of natural language queries, which direct the users not only to the document, the substance, reaction, or records, but also to the protein target, and for which the structure-activity relationship can be visualized easily on the Reaxys results page that you will see later in the demo. And more sophisticated and even complex search strategies can now be realized via the query builder. In the unforgettable year of 2020, of our modern history, the extensive Reaxys commercial substance database has been integrated. And then 1 year later, the patent database content was boosted with a large extension by adding patents from 105 patent offices and a complete exception last year of back to 2000 enriched with target information. And in the same year, the AI enhanced predictive retrosynthesis tool was implemented, helping scientists to predict scientifically robust synthesis routes backed by experimental procedures from the literature. And Reaxys also offers now research and discovery functions, metadata monitoring, and is being developed to integrate with other applications and services, and notably the Scopus and ScienceDirect, as we are used to and familiar with. And so now, where are we standing? Providing more than 280 million substances with more than 65 million reactions, more than 112 million documents, and more than 42 million patents covering 170 IPC discoverable within 5 days only of publication, and we have more than 46 million of bioactivities. This research tool has been successfully applied in various scientific fields as the world's largest chemical and bioactivity database supported by an effective interface for undergraduates, for graduates, researchers, and librarians. So the history proves that Reaxys continuously undergoes technological development to better meet the user needs, and your demands, reflecting a tradition of innovation. We have come so far. So this was a wonderful surprise for us today to have our colleague from product team to join in the last minute because he never has time. So let me introduce you now, Markus Fischer, who is based in Frankfurt. Well, by the way, I'm based not so far from Frankfurt, so just 1 hour. And we will give you an overview. So Markus will give you an overview of our current product roadmap. So Markus, the floor is yours. All right, Markus, the screen is yours now.
Thank you so much, Tanvi. And it's really a pleasure to give you some kind of overview of what has been recently improved within Reaxys, but also what we are working on going forward. And for today, I picked actually 4 highlights, which are all centered around the need now really after this massive expansion of the content we have accomplished over the last 3 years, so 4 years since 2021, to address the need now actually to navigate and identify the relevant information from this huge and vast document store we have now actually at our hands. So therefore, I would go with 2 recent improvements, which help you to navigate and identify relevant information within this context corpus, but also then what is coming further down the line this year. So as we talked about, the number of documents had massively expanded within Reaxys. So therefore, one problem will be if you search actually for those documents, how to identify the most relevant to you. And without going into the details here shown, I just want to point out that we recently actually released a new relevancy ranking, which means if you now start, for example, a search with keywords, you will see that the order of the documents you receive now has changed. And the underlying ranking is now actually tuned that more important information are coming up on top of the list so that you don't have to go through actually the entire list of hits, but you can be quite sure that the first 10, 20 records are all really relevant to your query, and that should give you a way easier access actually to the information you require for doing your research. So that is really one improvement, which I think is really important. Besides that, on the next slide, we will also see that let's assume you would actually start your research within Science Direct, just to get a high-level overview of what articles are actually for a given topic available. You now might have already seen that with articles which have chemistry-related information, you will now be actually also seeing substances and information for the substances around their properties, their commercial availability, but also what type of reactions are available, which are now highlighted in Science Direct. And those information actually is pulled from Reaxys, is then visualized in Science Direct. So that also gives you the opportunity to identify if an article you identify in Science Direct has relevant information for you if it comes to chemistry. If there is an interest to see then actually more information around the substances in Reaxys, these informations are also linked back to Reaxys, and through the linking, you can then directly open up the information in Reaxys and see then even more details around all the information which is available for those substances, but also then the related reactions, but also targets and bioactivity. So I think that is also very nice for especially starting a new research topic to identify information which is really relevant to you if it comes to chemistry related information. Now, those are the 2 highlights I wanted to point out, which recently have been released. Now we have 2 more highlights I want to point out what is coming down the road this year. And on the next slide, it is also about how to manage now actually all this information, and especially with the massive expansion of the patent space within Reaxys, it becomes now really important to quickly assess what information within the patents is of relevance to me. And now what we will introduce later this year is then what we call actually a feature which will allow you to group patents. So within Reaxys, we have the concept of a patent family, which actually is linking patents which have shared the same information but have been published or have been released in different kind of time frames together. So at the moment, if you would look for a specific patent and there are multiple patents associated with each other, you would just see actually each individual patent as an individual record. That obviously is not very convenient to get a quick overview of what is actually within those patents. This is where now the patent grouping comes to the help. So going forward, there will be actually as default the view of having all the patents grouped. You will see the group entry, which gives you a high-level overview of what to expect within those patents. And then you have the possibility to expand those patent families and see then actually all the details, like shown here on the right side, for all the individual patents within this group. That also should give you a quick opportunity to navigate the space. And as a last highlight for today, I have then actually another search improvement, which will help you with identifying relevant information. And that is really all centered around the very important use case of searching by a author name. Very often, it is so important to identify quickly who a colleague or a collaborator, what has been published. And for improving that experience going forward, we will actually introduce a new author search mechanism, which first of all will help you to identify variations of the name. So depending on how the publication is actually handling a specific offer, all the variations will be available to you. But then also the affiliation will be actually highlighted. So therefore, it is way easier than to identify the publications for a given individual you're interested in. And all that information will be available through the search interface, but then also there's the possibility for the filtering to accordingly identify the relevant information for a given person. With that said, I would be through with the presentation of the highlights and would then hand over to start with the demo.
Good morning, everyone, and thank you so much for joining today's webinar. And thank you also to my dear colleagues who have presented so far. My name is Giulia Moncelsi. I'm the solution engineer for Reaxys for academic and government institutions across Europe, Middle East, and Africa. So whenever you have a question around Reaxys, do not hesitate to reach out to me or to my colleagues on this call. Moving forward, so before going into the live demo of Reaxys and show you a little bit of the existing and new features that you can find there, I just wanted to refresh your knowledge about some of the highlights and features that you can find in Reaxys indeed. Just as a reminder, in Reaxys, you will be able to retrieve and produce result sets that are completely adjusted to your search needs. As a reminder regarding syntax and how to structure a search, Reaxys is able to interpret natural language as well as allowing the use of truncation, wildcards, and operators. And in our Reaxys Support Center, if you do not remember which wildcards, special characters, and operators are available for use, you will find help files that will guide you when you're structuring your search in Reaxys. Indeed, Reaxys is able to recognize your search intention in a very well-structured way, for example, by producing a preview list of results with different options. So for example, if you're looking at the preparation of a certain compound, Reaxys will most likely show you a hit list for chemical reactions, as well as different lists for documents that take into account one or more of the keywords that you have put as an input. And this is useful because you can get to the intended answers directly for your search, plus Reaxys will highlight relevant results that may have not been considered. We saw in the first poll that most of you are familiar with Reaxys, so possibly and probably you have made use of our quick search features, of our query builder, as well of our retrosynthesis planner. And Tanvi has very nicely highlighted some of the new features that are available in Reaxys for academic customers. And one of them is predictive retrosynthesis. And this allows for innovative synthesis planning. Now, we know that in the modern landscape, AI is everywhere, from chat-like programs to more complex and sophisticated search engines. And in Reaxys, we have included a predictive retrosynthesis feature completely embedded into our synthesis planner. And this has been done in partnership with a startup called Pending AI. And this is the underlying technology, which I will not go in detail with, but just so you know, the technology that powers the predictive retrosynthesis in Reaxys is able to learn chemical transformation rules from in-house Reaxys data. It also learns how to prioritize these rules and ultimately to predict reactions. And the data, as I mentioned, is coming from Reaxys. Specifically, we harness data coming from 15 million single-step reactions, from which the model can extract over 400,000 reaction rules. And the impact and results is shown here. The Reaxys predictive retrosynthesis is able to predict and produce scientifically robust routes for small drug-like organic molecules. And we're working on further developments on our predictive retrosynthesis capabilities, so also stay tuned on that for the foreseeable future. In the retrosynthesis planner in Reaxys, you're going to be able to view published, predicted, and even customized synthetic routes all in one view, as you can see there. You can also assess the commercial availability of starting materials that are needed for your synthesis. You can view at a glance the number of steps in a determined synthesis plan to choose at a glance which is the best one for your search needs, and also preview the route diversity with ease using the route topology feature. And you can all the while compare what has been predicted using the predicted retrosynthesis feature with examples, similar examples that are published in the literature. So you're very confident at all times that you're going in the right direction. Moving on to another very important feature in Reaxys, which is the target and bioactivity data and insights. Reaxys is also very well equipped to help you answer critical questions, for example, related to hit to lead and lead optimization in chemical biology, medicinal chemistry, and synthetic chemistry. For example, such questions might be what substances interact with a certain biological target, what type of interactions occur between a substance and the target of interest, comparison with similar structures, and comparing affinities as well. And of course, the bioactivity and target insights aim to accelerate the DMTA cycle, so the design, make, test, analyze cycle. As a practical example of what you can find in Reaxys that helps address these questions and helps accelerate the DMTA cycle would be the search of bioactivity properties for a certain substance. As you can see here, once you retrieve the data for a certain substance, you're going to be able to access its drug likeness, which is compared against the Lipinski and Weber's rules of thumb in a tabular and also graphic way. So you're going to be able to have this at a glance visualization of what your compound of interest exhibits in regards to drug likeness with respect to such rules, as well as you're going to be able to deep dive into the available bioactivity data for the compound of interest. There's much more, so you're going to be able to see efficacy studies, in vivo, in vitro studies, metabolic and pharmacokinetic profiles, as well as toxicity and safety data. And all of this is seamlessly embedded into Reaxys to give you an intuitive and user-friendly experience. We mentioned that Reaxys has evolved in recent years into the Reaxys Academic Edition. We've brought it all together to have to enable users to actually have together all the disciplines across chemistry and related sciences, and facilitate also inter and multidisciplinary research, which is ever so important. And now I will stop sharing so we can go live in Reaxys and explore the Reaxys Academic Edition. So bear with me 1 second as I switch screens. And in the meantime, I encourage you to ask questions in the chat, and then maybe we can also address while we're on this webinar together. Perfect. So you would now see my Reaxys screen. Just let me know if that's not the case. And since most of you on this webinar are somewhat familiar with Reaxys, we will now go through with the basics. If you have additional questions on, for example, how to structure a search or how to use the structure editor, where to find specific features, you can always contact us for a refresher training in Reaxys. I also warmly suggest you to make use of the resource center that you can access here, and will take you to a separate page that can answer the very basic questions and notions about Reaxys, as well as provide you with nice onboarding material and video tutorials. So this is always somewhere that you can refer to, a safe haven when navigating the wealth and breadth of knowledge that is contained in Reaxys. For the purposes of today's demonstration, I want to take you through a little journey that spans across substance searching to bioactivity data and also the retrosynthesis planner. So I will very quickly go to the structure editor, and instead of drawing by hand, I will use the insert structure from name feature. This is a very nice feature. You can enter a common chemical name, a CAS number, an INCHI key, or a SMILE string, which is what I'm gonna do now. So I have my SMILES copy pasted here, and this is my compound of interest, which I want to explore bioactivity data and also how to make this compound in the lab. Now you have three options actually. You can search for this structure as drawn, so only allowing for exact hits. You can also search it as a substructure on all atoms or heteroatoms only, and you can expand the variation on the molecular backbone by choosing the similar feature. I will leave it as drawn for now, and I will transfer to the query very simply. Okay. Oh, yeah, sorry. It just took a second more. Let me go back to quick search. Okay, let me just refresh the page. Sometimes it's just a network glitch, and you know, there's a few seconds delay. me try that again. Perfect. Transfer to query. Right. So now you can also complete the quick search for this compound using a keyword or a pair of keywords using the text-based search string. For example, you could input a biological target or a substance action on target for this one, but I wanted to show you what would be the kind of results that are retrieved for an exact search, for an exact match on this substance in Reaxys. And very nicely in the preview of results, you have a list of options. As I mentioned before, you have exact match substances, one biological target that is impacted by the substance, 33 documents, 7 substances with average similarity, 14 reactions, and commercial substances. Mind you that commercial substances are hosted in a separate environment than substances because there are different search filters associated to them. And very quickly, because this is something that you might find useful, you can go into the commercial substances environment and you will see that in the filters area, you're going to be able to select the availability, the commercial suppliers. You can actually set supplier preferences from your registered user profile. And you can even check the supplier's geolocation. So for example, since we're based in Europe, we're gonna want to exclude US-based suppliers, and then we can limit to that very easily. And then you're gonna be able to explore the heat data. And this is a nice table that shows you who's selling what, in what purity, package size and price, and availability. And you can keep on filtering using the table columns as an input to arrive to the commercial product and commercial supplier that suits your needs the most. Obviously, you can also export this information in several formats and have it available whenever you need. So this is very quickly a place for you to enable a make or buy decision. So should I make this compound, or is it commercially available, and is it convenient for me to buy, and where is shipping from, and what's the availability? So I think this is a very nice feature. If we go back to the preview, you might want to also check biological targets to have an idea of the impact of such substances against biological targets. And then, if available, for biological targets, we provide the hyperlink to the UniProt database. So if you click on it, you will have access to the target information from UniProt, which might be useful for you. And we also have additional details, so some synonyms and distribution of bioactivities and behavior over certain ligands. Now, imagine that I want to restrict my search, taking into account just a certain biological target and my substance action on target, right? So I can go to Query Builder and structure my search accordingly, or I can also take the substances that have been found and click on the Edit in Query Builder function. So now I'm in Query Builder environment, and Reaxys has already populated it with a structured querylet. Now I can, since I'm gonna restrict my search, but I want to allow for a little bit more flexibility regarding the retrieved substances, I will now switch to search as substructure and apply this. And now I will explore to the right side some search fields for bioactivity. Mind you that there's a plethora of fields that are related to topics and keywords of searching, identification of chemical compounds, physical and spectral properties, target and bioactivity, reaction data, etc. You can also search certain fields. So if I input target, now I will get a set of querylets that have target in it. So I want to input the target name as well as the substance action on target. And as you can see, now I'm populating the query builder further. I will choose the NLRP3 target, and the substance action on target would be agonist. So you can, keep on populating and building on this query. This will allow you to have a more refined structure. You can also save this for the future. So you can save the query offline, or you can save the form online. If you choose to save the form, you can keep it in Reaxys, including current values. So imagine I choose this name and I save. I can retrieve it from my forms, and now it will be here, including all of the data of input. So that's very convenient. Further on in Query Builder, you can already choose where to search for the information of interest. You can go into substances. And now, as you can see, because we've allowed for more flexibility on a molecular scaffold, you can see different substances here. And you can switch to the grid view, which will give you a better idea at a glance of what kind of compounds have been retrieved. Obviously, you can zoom in and see it better. What else you can do? You can go back to lists, and then you could explore physicochemical and bioactivity properties for all of these compounds. These are all here for you to peruse, as well as you can go directly into reaction searching by target data and documents. So let's go into properties first. You will have drop-down menus for identification of compounds. Then, as I mentioned, you will have the possibility to explore drug likeness. And very nicely, it seems like this compound respects all of the Lipinski and Weber rules. You can see that graphically very easily, but you can also check numeric and quantitative values from these two tables divided per component. And you have also the number of matches of rules that are matched for Lipinski and Weber. So if this is something that you work with, you might want to check it. And then you have bioactivity data. All of it, all that is available for a particular compound. You have efficacy in vitro, metabolic and pharmacokinetic data. And because we've structured our search to find target agonist information, you also have an additional menu that says hit data for bioactivity. And then it will filter the available bioactivity data for the properties that you wanted to discover. And when a hit is found, it will also be highlighted in this kind of like gray-blue color. So the action on target is indeed agonist, and the target is the one that we specified. And this includes synonyms. So if you don't recognize at a glance the target, just be aware of all the synonyms that it can have. And so very neatly, we organize our bioactivity data with px. Px is the negative logarithm of x, which will be your bioactivity parameter of interest. If you wish to select by a certain parameter, you can also do so using the parameters filter on the left side. You can change the target, and you can also filter by px, choosing the range of interest. So the higher the px, the higher the affinity of the substance to target interaction. And in the bioactivity tables, you will be able to find additional information that is experimentally reported and peer-reviewed, and always with a bibliographic reference at the very end of the table, so you're sure that this has been experimentally validated. You can also have a pool of substances, and you might be interested in having at a glance the visualization of bioactivity. Very simply, you can click on bioactivity visualization. Now, it's gonna look very quite kind of simple, because we have selected one target of interest to start with, right? So we want to assess the bioactivity of this substance against this target. So you have the 33 substances available here, and you can also disable the navigator and peruse the bioactivity data manually, and the target here. Now, for substances and target, you can click on the 3 dots and also sort by activity. That means that the highest px values are going to be at the top. And so you can see now there's a gradient of color. What does it mean? If you go to the legend, you will see that the warmer the color, the higher the px value. So sometimes it can be very useful to sort by activity, especially if you're looking at a certain target or a certain substance. Moreover, here you can access the result filters again and modify the bioactivity visualization as you please. If you want to go back to substances, you just click on the substances view, and that will immediately take you back there. You can also go back to Query Builder, so the search is retained, and you could explore other results such as documents. In this case, it appears there's only 2 documents that report all of the information that we have required. You can find a hit substance or substances. For example, for this patent, there's 33 substances. And for this document, there's 1. And for documents, just as a reminder, you're going to be able to check the abstract, substances, reaction, index terms, targets, and then there's always a full link to the full text. For patents, I take this as an example because it's a patent, we also extract the patent claims in full, the bibliographic information, so this might be particularly convenient if you're searching for patents a lot, or you're about to file a patent and you want to find more information, as well as substances, reaction targets, and the full text link. And for patents, we also extract all the information that is extracted is translated promptly into English, no matter where the patent is coming from. So this is to provide further consistency in your searches, and obviously to not have you go to the patent repository and have to use tools like Google Translate. So all of that is possible already in Reaxys. Now, we can also explore reaction data. So the final part of my demonstration is going to be about showing you a little bit of the retrosynthesis planner possibilities. Now, if you go into reaction results, you have relevant filters. You could filter by yield. You could filter by a certain reagent of catalyst. So you have several options to refine the result set for the reactions. Very importantly, when you have a reaction scheme, you have access to also the experimental conditions. at a glance, complete with yield whenever reported and the reference. But also, whenever possible, we excerpt in full the experimental procedure as reported originally in the article or paper or patent. So as you can see here, very nicely, you have the full experimental procedure. Again, avoiding you to use extra time to go into the original patent or article and check that for yourselves. Now you will notice this very cute reaction flask under each of the starting materials, as well as the reaction product and reaction scheme. So you have the possibility to transfer a single molecule to the retrosynthesis planner or the entire reaction scheme. That is particularly useful if you want to keep it in the retrosynthesis planner, for example, but you could also, save this in the history of searches as a reaction search. Now, what we're going to do is we're going to take our molecule of interest and create a retrosynthesis plan. This is one way of doing that. The other way is to draw entirely the new compound. So you can use the structure editor and with the same inputs, but also here you're going to be able to choose whether you want to make use of the published reaction data, and you can toggle some of these settings manually to enable this, or you can use the predicted retrosynthesis feature. And here again, you have several bullet points that help you structure a predicted retrosynthesis search, including changing processing time from a standard of 10 minutes to an extended time of 30 minutes, and select building block libraries based on availability and price. So the very nice thing is that you're also gonna be able to have different synthesis projects running at the same time, so you can keep on adding that, and Reaxys will run all of them in the background. And the other nice thing is that over time you will be able to build a synthesis projects library. So as you can see here, these are all different synthesis projects that you can retrieve whenever you need them. You can delete them, you can rename them, and you can see on the right hand side what kind of results they have retrieved. So as you can see, I've run a couple of searches for this same compound before we started the webinar. In one, I used published and predicted reaction data. Reaction settings, and in one I just use the predicted data. So we can use the second one to highlight the predicted retrosynthesis feature, because for the published data you've already seen it from the reaction results. And yes, and here, for example, you have at a glance the predicted routes. You have this is not the final view. This is a preview of all the available predicted routes. You have here the building blocks, the route topology that you can check at a glance. So in this case, there's 8 steps to the final product, and a confidence score that informs you how good is the predicted route, and it goes from 0 to 1, 1 being the best. So this is an almost perfect predicted route. And then you can go to the tree view, which is the final view. And here you can obviously zoom in and see the routes in its entirety. You can fit view to have it at a glance. And on the right side, but you can change this view very easily, you're going to be able to scroll alongside the different reaction steps. And since it's a predicted route, the steps are judged or are scored against reported examples available in the literature. So you have a second scoring system here called the similarity score that tells you how similar is the predicted route to one that is reported in the literature. So you're also going to be able to check the reported literature as we go along. And as a final note, for all synthetic procedures that are discoverable in the retrosynthesis planner, you are going to be able to add reaction steps, delete prior steps at a step level, as well as you can pick a starting material such as this one, and you will see a plus icon. And this will allow you to complement and customize this synthetic route by adding optional single steps. So for example, very quickly, if we do that and we add it to the synthetic procedure, Reaxys will produce a new one, which is color-coded in yellow, that contains the extra step that we just produced. Again, as a final note, we have several exporting formats available, and you can also select some examples per step, the ones that look most promising to you, and just limit the view to the selected examples. As you can see, now this has been filtered for. So because I want to leave some time for the Q&A, I will stop the demo, and we can welcome you all to the Q&A.
Thank you, Julia. What a fantastic demo. Thank you, everyone. So now it's time for the Q&A session. So make sure to put all your questions on the box, on the Q&A box. And as I wrote on the chat, we're going to try to address as many as possible within the time we have. And those that we cannot answer now will be followed up later by email. And just before we jump into the questions, I just would like to remind you that I'm going to be open a feedback survey that you can be answering throughout the Q&A process. Please, your feedback is so important. It's what helps us shape the future webinars. We'd love to understand what kind of topics you would like to see in the next sessions. So if you can take 1 minute or two just to be answering those questions while we're answering the Q&A would be brilliant. All right, let's jump into the first question. It says, can you export bioactivity visualization?
Yes, you can. I will take this one. As I mentioned, there's always an export feature available, and that's also the case for bioactivity visualization. And actually, since very recently, we have a new export format in Excel that allows you to export the full bioactivity visualization, complete with chemical structures for your substances and the target names and the px values. I think the only thing that is not exported is the color coding, but that's something that you can for now survive with.
Thank you, Julia. I saw a lot of questions coming regarding to the recording or people who join a little bit later. Just a quick reminder, we will be sharing the recording of the session later on through the thank you email. So keep an eye into your mailbox in the coming days. You should be receiving a thank you email with the recording. Next question. I hear a lot about predictive tools. How is Reaxys different than the others?
Not sure if Marcus or Tanvi want to add something.
To jump in? Yeah.
So it depends on to what to compare, obviously, the algorithm. So if it comes to the retrosynthesis predictive tool which we provide, it is using, from the technology perspective, a template-based approach. Meaning, what Julia also mentioned, we utilize, or our partner is utilizing our reaction data set and is identifying then automatically within the preparation process those rule sets, which are then are used to train actually a neural network on top of it. So that is quite a common approach and has been proven to be actually extremely powerful and in terms of the performance, but also maintainability and updating than the underlying predictor. Now there are different approaches which also could be utilized to do so. There are other systems which are using a rule-based approach where the rules are more or less defined in a curated fashion. So it's not that those rules would be identified automatically and then the system would be trained upon, but it is a more heuristic approach. That obviously is hardly scalable and is focusing more on specific transformations and chemical reactions, which can be covered in this type of compilation of manual rule sets. And then there are other approaches out there, which are so-called template-3 approaches, where it is more than going along these lines, where the information tries to be identified just based on the components, which are starting materials and reactions, without really considering the chemistry itself. So it tries to learn the chemistry by simply looking at the reaction paths. Those are also out there, but also have obviously certain kind of advantages and disadvantages over the template. So from our experience, the template based approach we are using is really the most robust approach, which gives you really good scientific, robust and solid results. Plus, it is actually also scalable and updatable in comparison to other approaches.
Thank you all for joining. Don't forget to scan the QR code. We're also going to be launching very soon in the coming months our Elsevier Global Chemistry Landscape Report. So if you have time to scan this QR code, this is a pre-registration for the launch of such report. And also, we're very, very happy to see you all at UCAMS this summer. We will have a few workshops. We will have the Reaxys booth. So we're very excited to see you there. And for any other questions, please feel free to contact myself and Tanvi, and we will be happy to follow up.